Alright, here's a question for you. Can you actually move? I'm serious. Right now you're sitting there, or standing, or walking, whatever. And you probably think that's the most obvious thing in the world. Of course you can move. You do it constantly. You've been doing it your whole life. But what if I told you that a philosopher from 2,500 years ago constructed arguments, logical, rigorous arguments, that seem to prove you can't? That motion itself might be impossible. That the simple act of walking across a room involves completing an infinite number of tasks which should be, well, impossible? Welcome to the world of Zeno of Elea. And trust me, this is going to get weird. Now you might be thinking, okay, obviously this is wrong. I just moved my hand. Paradox solved. But here's the thing. Some of the greatest minds in human history have wrestled with Zeno's paradoxes. Aristotle spent serious time on them. Medieval philosophers obsessed over them. The development of calculus in the 19th century was partly a response to them. And even today, physicists and philosophers still debate whether we've actually resolved what Zeno was getting at. These aren't just ancient brain teasers. These are arguments that expose something genuinely strange about reality, about space, time, infinity, and the basic structure of the world we live in. See, Zeno wasn't trying to be difficult for the sake of it. He had a mission. His teacher, Parmenides, had made this absolutely wild claim about reality, something so counterintuitive that people were laughing it off. And Zeno decided to defend his teacher's idea using one of the most powerful weapons in philosophy, showing that the common sense view leads to contradictions so absurd, so logically impossible that maybe, just maybe, the crazy-sounding alternative deserves another look. What's remarkable is that Zeno's method, this technique of taking an opponent's position and showing it collapses under its own logic, became one of the foundational tools of Western philosophy. We call it reductio ad absurdum, and you've probably used it yourself without realizing it. If what you're saying is true, then this ridiculous thing would follow, so you must be wrong. That's Zeno's legacy right there. But the paradoxes themselves, they're not just historical curiosities. They're alive. They're still challenging us. Because at their core, they're asking questions we still don't have perfect answers to. What is time, really? What is space? Can something actually be infinitely divisible? How do we get from point A to point B if there are infinite steps in between? So buckle up. We're about to dive into some arguments that will make your brain hurt in the best possible way. Arguments that seem simple on the surface but open up into these vast philosophical chasms. Arguments that made ancient Greeks question reality itself, and should make you question it too. So who was this guy who decided to convince everyone that motion is an illusion? Zeno was born around 490 BCE in Elea. That's a Greek colony in southern Italy, not mainland Greece. This is important because some of the most radical philosophical thinking in ancient Greece didn't happen in Athens. It happened in these colonies, these outposts where maybe people felt a bit freer to challenge everything, to think differently. Elea became the home of some seriously revolutionary ideas about reality. And Zeno? He was the devoted student of Parmenides. Not just a student, more like a philosophical bodyguard. Parmenides had developed this mind-bending theory about reality, and Zeno made it his life's work to defend it. We're talking serious intellectual loyalty here. Now here's the frustrating part for us. We don't have Zeno's original writings. They're gone. Lost to time like so much of ancient philosophy. What we know about Zeno comes primarily from Plato's dialogue, Parmenides, written decades after Zeno lived, and from later commentators who referenced his arguments. It's like trying to understand a movie you've never seen by reading reviews and hearing people quote their favorite lines. We're getting the ideas secondhand, filtered through other philosophers' interpretations, but you know what? The ideas survived. And they survived because they were so powerful, so provocative, that people couldn't stop talking about them. Even in fragments, even in secondhand reports, Zeno's paradoxes had this way of getting under people's skin. So what was Zeno defending? What was Parmenides' big idea that needed this kind of philosophical backup? Here it is, and I want you to really hear how radical this is. Parmenides claimed that reality is one, eternal, and completely unchanging. Everything you see changing around you, the seasons, your body aging, water boiling, people moving, all of it is illusion. Not real change, just the appearance of change. True reality, true being with a capital B, is one unified thing that never changes, never moves, never becomes anything other than what it eternally is. I mean, think about that. You're sitting there watching yourself breathe, watching things happen, experiencing change constantly, and Parmenides is saying, nope, that's not real. Reality is one unchanging thing, and what you're experiencing is just appearance, illusion. Your senses are lying to you. People must have thought he was absolutely out of his mind, and this is where Zeno comes in. He's not trying to prove Parmenides is right directly. That's too hard. Instead, he's going to show that the alternative, the common sense view that there are many things, that things move and change, leads to logical contradictions so severe, so impossible to resolve, that maybe Parmenides' crazy-sounding view isn't so crazy after all. This is Zeno's signature move. Reductio ad absurdum. Take your opponent's position, follow it to its logical conclusions, and show that it leads to absurdity. If believing in motion leads to impossible contradictions, then maybe motion isn't real. If believing in plurality, in many separate things, leads to logical nightmares, then maybe there's really just the one. It's philosophical judo. Use your opponent's own position against them. And here's what makes Zeno so important. He didn't just defend Parmenides. He invented a method that became central to philosophical reasoning for the next 2.5 millennia. Every time you hear someone say, well, if that were true, then this impossible thing would follow. That's Zeno's technique. Every time a mathematician proves something by assuming the opposite and deriving a contradiction, that's Zeno's legacy. But the paradoxes themselves, the paradoxes, they're not just logical exercises. They're these beautiful, maddening arguments that take something utterly ordinary, walking across a room, an arrow flying through the air, Achilles running, and show you that hidden inside these everyday experiences are genuine mysteries about the nature of reality. Zeno constructed about 40 paradoxes, according to ancient sources. Most are lost. But the ones that survived, they're enough. They're more than enough. They've been puzzling people for 25 centuries, and they're not done yet. So let's see what this philosophical troublemaker came up with. Let's see how he tried to prove that everything you think you know about reality is wrong. All right, before we get to the paradoxes themselves, we need to understand exactly what Zeno was fighting for, because his arguments only make sense when you grasp how absolutely radical Parmenides' vision of reality was. So let's slow down for a second and really sit with this. Parmenides said reality is one, not mostly one with some parts, not unified despite appearances, literally one thing. Eternal, unchanging, indivisible. What truly exists cannot come into being, cannot cease to be, cannot change in any way. It simply is. Now, your immediate reaction is probably, that's obviously false. I can see multiple things right now. Things are clearly changing. I just watched the second hand move on the clock. Right. Exactly. That's everyone's reaction. And Parmenides' response was essentially, your senses are deceiving you. What you call seeing many things and observing change is appearance, not reality. True being, capital B, is one, eternal, unchanging. This is monism in its most extreme form. Not just everything is connected or there's a unity underlying diversity. No, there is no diversity. There's only the one. Everything else is illusion. You can imagine how well this went over. Picture Parmenides at the ancient equivalent of an academic conference. Actually, nothing you perceive is real. Change is impossible. Motion is impossible. You're all experiencing a kind of cosmic hallucination. Yeah, people weren't buying it. And this is where Zeno steps up. He's looking at his teacher getting dismissed, maybe even mocked, and he thinks, okay, you think Parmenides is crazy? Let me show you what happens when you believe the sensible alternative. Let me show you that your view, the common sense view, is actually the one that's logically incoherent. Zeno's mission was defensive. He wasn't trying to prove monism directly. He was trying to show that pluralism, the belief that many things exist, and the belief in motion and change lead to contradictions so severe, so impossible to resolve, that maybe, just maybe, the crazy view deserves another look. This is philosophical warfare. And Zeno's weapon? Pure logic. His strategy was brilliant. Don't attack the senses directly. Don't argue about what we perceive. Instead, take the logical implications of what people believe and show that they lead to absurdity. Show that if you really think there are many things, or if you really think motion is real, you're committed to impossible conclusions. It's like someone saying, I believe in X, And you responding, okay, but if X is true, then Y must be true, and if Y is true, then Z must be true, and Z is obviously impossible, so X can't be true either. Reductio ad absurdum, reduction to absurdity, and Zeno wielded it like a master. Now here's what makes this so philosophically important. Zeno forced people to take Parmenides seriously, not by proving him right, but by showing that the alternatives were logically problematic. He shifted the burden of proof. Suddenly it wasn't enough to just point at the world and say, obviously there are many things and they move. You had to explain how that's logically possible given Zeno's arguments. And people have been trying to do that ever since. The Eleatic school, Parmenides, Zeno, and their followers, created this incredible intellectual crisis. They challenged the most basic assumptions about reality. They made people question whether their senses could be trusted. They forced philosophers to develop better logical tools, better ways of thinking about infinity, continuity, space, and time. Think about what they were claiming. Everything you see is wrong. The world isn't what it appears to be. Reality is fundamentally different from experience. Sound familiar? It should, because this same pattern shows up again and again in philosophy and science. Copernicus. Actually, the Earth moves, not the sun. Einstein. Actually, time and space are relative, not absolute. Quantum mechanics. Actually, particles don't have definite properties until measured. The Eleatics were maybe the first to make this move in Western philosophy, to say that reality is radically different from appearance, and that reason, not the senses, is our guide to truth. Now, did they get it right? Is reality really one unchanging thing? Most philosophers today would say no. But that's not the point. The point is that they asked the question. They forced us to justify our beliefs about plurality and change rather than just assuming them. They showed that what seems obvious might not be true. And Zeno's paradoxes? They're the ammunition in this philosophical revolution. They're the arguments that made people stop and think, wait, maybe this isn't as simple as I thought. So let's see how he did it. Let's see how Zeno tried to prove that if you believe in many things, in plurality, you're already in logical trouble. Okay, so Zeno's first target, the idea that there are many things, multiple separate, distinct things, like everything you see around you. This seems like the easiest thing in the world to defend, right? Are there many things? Yeah. Look around. There's my coffee cup, there's the table, there's you, there's me. Many things. Done. But Zeno says, not so fast. Let's think about what it means for there to be many things. Here's the argument, and I want you to follow each step carefully because this is where it gets interesting. If many things exist, if there's genuine plurality, then each of these things must be distinct, separate, individual. They can't be the same thing, or they wouldn't be many. Agreed? Okay. Now, for something to be a distinct thing, it has to have some kind of boundary, some way of being separate from other things. And if it's a physical thing, it has to have parts or be divisible in some way. Even if it's very small, it occupies some space, has some extension. Still with me? Nothing controversial yet. But here's where Zeno springs the trap. If a thing has extension, if it occupies space, then it's divisible. You can divide it into parts. And those parts, they're also things that occupy space, so they're divisible too. And their parts are divisible. And so on. Picture it. You take something, anything, and cut it in half. Then you cut those halves in half, then those quarters in half, and you keep going, and going, and going. Where does it stop? If it stops, if you reach some smallest indivisible part, then that part has no extension, no size. It's a point. But here's the problem. How do you build something with size out of things that have no size? If you add up 0 plus 0 plus 0 even infinite times, you still get 0. So the original thing should have no size either. Which is absurd. It clearly has size. Okay, so maybe the division never stops. Maybe it's infinite. Maybe there's no smallest part. You can always divide further. But now you have a different problem. If something is made of infinitely many parts, what's the size of each part? If each part has 0 size, we're back to the same problem. Infinite zeros still equal 0. But if each part has some finite size, even the tiniest amount, then when you add up infinitely many of them, you get infinity. The original thing should be infinitely large, which is also absurd. You see the trap? Either way leads to impossibility. If things are made of parts with no size, the whole has no size. If things are made of parts with size, the whole is infinitely large. Both conclusions are absurd. Therefore, the assumption that led us here, that many distinct things exist, must be false. Now I know what you're thinking, but things clearly have size. This is just a logic trick. Maybe, but here's what makes this a genuine paradox rather than just sophistry. Zeno has identified a real problem with infinite divisibility. This isn't just word games. This is exposing a tension between our intuitive understanding of physical objects and the logical implications of infinite division. And you know what's wild? This paradox touches on issues that are still live in physics today. Is space infinitely divisible, or is there a smallest possible length, a Planck length, in modern physics? Are particles really indivisible, or can they be divided further? What is the fundamental structure of matter? The ancient atomists, Democritus and others, actually responded to Zeno by proposing atoms, indivisible particles that can't be divided further. They were trying to avoid this exact paradox, and while modern atoms aren't truly indivisible, we can split them, the instinct was right. There does seem to be a fundamental level where division stops. But even modern physics hasn't completely resolved the philosophical puzzle. Quantum field theory treats particles as excitations in fields. String theory proposes one-dimensional strings as fundamental. We're still grappling with the question, what are things ultimately made of? And can that ultimate stuff be divided or not? Zeno's paradox of plurality forces us to confront these questions. It shows that the simple statement, many things exist, hides deep puzzles about composition, division, infinity, and the nature of physical reality. And this is just his opening move. This is Zeno warming up. Because if attacking plurality wasn't enough, he's about to go after something even more fundamental, even more obviously true. Motion. The idea that things can move from one place to another. And when Zeno attacks motion, he doesn't mess around. He's about to argue that the simplest act, walking across a room, is logically impossible. Let's see how he does it. Slide 5. The Dichotomy Paradox. The race that never ends. All right, let's talk about motion. Simple, everyday motion. You're sitting there. I'm standing here. You want to walk over to where I am. Easy, right? You've done this a million times. You stand up, you walk, you arrive, done. Except, Zeno says you can't. You literally cannot get from where you are to where I am. Not because of any physical obstacle, but because of pure logic. Welcome to the Dichotomy Paradox, and this one is going to make your brain hurt. Here's how it works. Pay attention to each step because this is where things get genuinely strange. Before you can reach me, you first have to reach the halfway point between us, right? That's obvious. You can't get all the way here without first getting halfway here. Okay, but before you can reach that halfway point, you first have to reach the halfway point to the halfway point, the quarter mark. You can't skip it. You have to pass through it. And before you can reach the quarter mark, you have to reach the halfway point to that, the 8th mark. And before that, the 16th mark. And before that, the 32nd mark. You see where this is going? There's an infinite sequence of halfway points you must pass through before you can complete any journey. Before you can get to me, you must first complete an infinite number of subjourneys, an infinite number of tasks. And here's the killer question. How can you complete an infinite number of tasks in finite time? Think about what infinity means. It's not just a really big number. It's unending. No matter how many halfway points you pass, there are always infinitely many more ahead of you. You never finish an infinite sequence. That's what makes it infinite. So if motion requires completing an infinite sequence of steps, motion should be impossible. You shouldn't be able to start moving, because there's no first step to take. There's always a prior halfway point. And you shouldn't be able to finish moving, because there's no last step. There's always another halfway point ahead. Now your immediate reaction is probably, but I can walk across the room. I do it all the time. I'm doing it right now in my head. Paradox solved. Right. And that's exactly what makes this a genuine paradox. Your experience clearly contradicts the logic. You know you can move, but the argument seems airtight. So what gives? This is what separates a real paradox from just a bad argument. A bad argument has a flaw you can point to. A real paradox has premises that seem true, logic that seems valid, but a conclusion that seems impossible. Something's wrong, but it's not obvious what. Let's be clear about what Zeno is not saying. He's not saying motion is difficult. He's not saying it's improbable. He's saying it's logically impossible, that the very concept of continuous motion through infinitely divisible space leads to contradiction. And people have been trying to solve this for over 2,000 years. Aristotle took a crack at it. He distinguished between potential and actual infinity. He said that space is potentially infinitely divisible. You could keep dividing it, but you don't actually divide it into infinite parts when you walk. You just traverse it as a continuous whole. That's not a bad response. But does it really solve the problem? Because the halfway points exist whether you think about them or not. You do pass through them. So how do you pass through infinitely many of them? Fast forward to the 19th century. Mathematicians developed calculus and the theory of infinite series. They showed that you can sum an infinite series and get a finite result. The infinite series 1, 2 plus 1, 4 plus 1, 8 plus 1, 16 converges to 1. Mathematically, infinite tasks can have a finite sum. So problem solved, right? Mathematics shows that infinite division is fine? Well, maybe mathematically. But philosophically, the puzzle remains. Because Zeno isn't just asking about mathematical sums. He's asking about actual physical completion of tasks. Even if the mathematical sum is finite, you still have to complete infinitely many individual steps. How do you do that? What does it even mean to complete an infinite sequence? Think about it this way. Imagine counting. You count 1, 2, 3, 4. Can you count to infinity? No, obviously not. Infinity isn't a number you can reach. It's endless by definition. But walking across the room requires passing through infinitely many points. So how is that different from counting to infinity? Why is one possible and the other not? Modern physics adds another wrinkle. Some theories suggest space might not be infinitely divisible. There might be a smallest possible length, the Planck length, about 10^35 meters. If that's true, then there aren't infinitely many halfway points. There's a finite, though incredibly large number of smallest possible steps. But that just trades one puzzle for another. If space is discrete rather than continuous, how does motion work at that level? Do things jump from one Planck length position to the next? What does that even mean? Here's what makes the dichotomy paradox so powerful. It takes something utterly mundane, walking, and reveals hidden assumptions we make about space, time, and infinity. It shows that continuous motion through continuous space is conceptually puzzling in ways we don't usually notice. And Zeno's just getting started. Because if you think the dichotomy is bad, wait until you meet Achilles and the tortoise. Alright, let's talk about motion. Simple, everyday motion. You're sitting there, I'm standing here. You want to walk over to where I am. Easy, right? You've done this a million times. You stand up, you walk, you arrive. Done. Except, Zeno says you can't. You literally cannot get from where you are to where I am. Not because of any physical obstacle, but because of pure logic. Welcome to the dichotomy paradox. And this one? This one is going to make your brain hurt. Here's how it works. Pay attention to each step because this is where things get genuinely strange. Before you can reach me, you first have to reach the halfway point between us, right? That's obvious. You can't get all the way here without first getting halfway here. Okay, but before you can reach that halfway point, you first have to reach the halfway point to the halfway point. The quarter mark. You can't skip it, you have to pass through it. And before you can reach the quarter mark, you have to reach the halfway point to that, the 8th mark, and before that, the 16th mark, and before that, the 32nd mark. You see where this is going? There's an infinite sequence of halfway points you must pass through before you can complete any journey. Before you can get to me, you must first complete an infinite number of subjourneys, an infinite number of tasks. And here's the killer question. How can you complete an infinite number of tasks in finite time? Think about what infinity means. It's not just a really big number. It's unending. No matter how many halfway points you pass, there are always infinitely many more ahead of you. You never finish an infinite sequence. That's what makes it infinite. So if motion requires completing an infinite sequence of steps, motion should be impossible. You shouldn't be able to start moving, because there's no first step to take. There's always a prior halfway point. And you shouldn't be able to finish moving, because there's no last step. There's always another halfway point ahead. Now your immediate reaction is probably, but I can walk across the room. I do it all the time. I'm doing it right now in my head. Paradox solved. Right. And that's exactly what makes this a genuine paradox. Your experience clearly contradicts the logic. You know you can move, but the argument seems airtight. So what gives? This is what separates a real paradox from just a bad argument. A bad argument has a flaw you can point to. A real paradox has premises that seem true, logic that seems valid, but a conclusion that seems impossible. Something's wrong, but it's not obvious what. Let's be clear about what Zeno is not saying. He's not saying motion is difficult. He's not saying it's improbable. He's saying it's logically impossible, that the very concept of continuous motion through infinitely divisible space leads to contradiction. And people have been trying to solve this for over 2,000 years. Aristotle took a crack at it. He distinguished between potential and actual infinity. He said that space is potentially infinitely divisible. You could keep dividing it, but you don't actually divide it into infinite parts when you walk. You just traverse it as a continuous whole. That's not a bad response. But does it really solve the problem? Because the halfway points exist whether you think about them or not. You do pass through them. So how do you pass through infinitely many of them? Fast forward to the 19th century. Mathematicians developed calculus and the theory of infinite series. They showed that you can sum an infinite series and get a finite result. The infinite series 1, 2 plus 1, 4 plus 1, 8 plus 1, 16 converges to 1. Mathematically, infinite tasks can have a finite sum. So problem solved, right? Mathematics shows that infinite division is fine? Well, maybe mathematically. But philosophically, the puzzle remains. Because Zeno isn't just asking about mathematical sums. He's asking about actual physical completion of tasks. Even if the mathematical sum is finite, you still have to complete infinitely many individual steps. How do you do that? What does it even mean to complete an infinite sequence? Think about it this way. Imagine counting. You count 1, 2, 3, 4. Can you count to infinity? No, obviously not. Infinity isn't a number you can reach. It's endless by definition. But walking across the room requires passing through infinitely many points. So how is that different from counting to infinity? Why is one possible and the other not? Modern physics adds another wrinkle. Some theories suggest space might not be infinitely divisible. There might be a smallest possible length, the Planck length, about 10^35 meters. If that's true, then there aren't infinitely many halfway points. There's a finite, though incredibly large number of smallest possible steps. But that just trades one puzzle for another. If space is discrete rather than continuous, how does motion work at that level? Do things jump from one Planck length position to the next? What does that even mean? Here's what makes the dichotomy paradox so powerful. It takes something utterly mundane, walking, and reveals hidden assumptions we make about space, time, and infinity. It shows that continuous motion through continuous space is conceptually puzzling in ways we don't usually notice. And Zeno's just getting started. Because if you think the dichotomy is bad, wait until you meet Achilles and the tortoise. Okay, so the dichotomy showed that starting motion is problematic. Now let's talk about catching up. Because Zeno has another paradox that's even more famous, even more maddening. Picture this. Achilles, the greatest warrior in Greek mythology, swift-footed Achilles, decides to race a tortoise. Because he's a good sport, he gives the tortoise a head start. Let's say 100 meters. The race begins. Achilles runs. He's fast, way faster than the tortoise. This should be over quickly, right? But here's what Zeno noticed. By the time Achilles reaches the 100-meter mark, where the tortoise started, the tortoise has moved ahead. Not far because it's slow, but it's moved. Let's say it's now at 110 meters. Okay, so Achilles keeps running. He reaches the 110-meter mark. But in the time it took him to get there, the tortoise has moved again. Now it's at 111 meters. Achilles reaches 111 meters. The tortoise is at 111.1 meters. Achilles reaches 111.1 meters. The tortoise is at 111.11 meters. You see the pattern? Every time Achilles reaches where the tortoise was, the tortoise has moved a bit further ahead. The gap keeps shrinking, but it never closes. Achilles gets closer and closer, but he never actually catches up. According to this logic, the fastest runner in Greek mythology cannot overtake a tortoise. Now, obviously, in reality, Achilles would blow past the tortoise. We know this, but that's not the point. The point is, where's the flaw in the logic? Because each individual step seems correct. The tortoise does move while Achilles is catching up. So when exactly does Achilles overtake it? This is the same structure as the dichotomy, but it feels different somehow. It's more vivid, more concrete. It's not about abstract halfway points, it's about an actual race with actual competitors. And what Zeno is showing is that if you analyze motion as a series of discrete moments, if you break it down into, first Achilles is here, then he's there, you can never find the moment where he overtakes the tortoise. There's always another interval to consider, another gap to close. The mathematical response is the same as before. Infinite series can converge. The sum of all those shrinking intervals is finite. Achilles does catch up, mathematically speaking. But again, and I want to emphasize this, the mathematical solution doesn't necessarily dissolve the philosophical puzzle. Because we're not just asking, does the math work out? We're asking, what is actually happening when Achilles runs? Is motion really continuous? Or is it a series of discrete positions? If it's continuous, how do we make sense of infinite divisibility? If it's discrete, how do we explain the smoothness of motion? These aren't just ancient puzzles. These are questions that matter for understanding the fundamental nature of reality. But okay, let's say you're not convinced. Let's say you think motion is obviously real, and these paradoxes are just logic tricks. Let me hit you with one more. And this one is subtle. This one goes deep. The arrow paradox. Picture an arrow in flight. It's moving through the air, heading toward its target. Now, consider any single instant of time, not a duration, an instant. A point in time with no length, no extension. Just a frozen moment. At that instant, where is the arrow? Well, it's somewhere specific. It occupies a specific position in space. At that instant, the arrow is right there, at that exact location. But if the arrow occupies a specific position at that instant, is it moving during that instant? Think about it. To move means to change position. But at an instant, a point in time with no duration, there's no time for position to change. The arrow is just there, at that position. Stationary. So at any given instant, the arrow is not moving, it's at rest. But time is composed entirely of instants, right? It's made up of these point-like moments. And if at every single instant the arrow is at rest, not moving, then when is it moving? How can motion be composed of motionless moments? This is different from the other paradoxes. This isn't about infinite division of space. This is about the nature of time itself. This is about what it means for something to be at, an instant versus during an interval. Aristotle really struggled with this one. He argued that motion doesn't exist at an instant. It only exists over an interval of time. An instant is too small to contain motion. Motion is something that happens across time, not in time. That's actually pretty sophisticated. But does it solve the problem because the arrow is somewhere at each instant? And those instants make up time. So how does being at a sequence of positions constitute motion? Modern physics has interesting things to say here. In relativity, we talk about world lines, the path an object traces through spacetime. Motion isn't something that happens in space over time. It's a feature of the object's world line through four-dimensional spacetime. But that's describing motion differently, not necessarily solving Zeno's paradox. We're still left wondering, what is motion fundamentally? Is it real, or is it just our perception of a series of static states? Quantum mechanics adds another layer. At the quantum level, particles don't have definite positions until measured. They exist in superposition, so asking, where is the particle at this instant, doesn't even have a determinate answer. Motion at the quantum level is genuinely strange. Particles can tunnel through barriers, exist in multiple states simultaneously. So maybe Zeno was onto something. Maybe motion isn't what it appears to be. Maybe at the fundamental level, reality is stranger than our everyday experience suggests. Here's what ties these paradoxes together: Achilles, the arrow, the dichotomy. They all expose tensions between our intuitive understanding of motion and the logical analysis of what motion requires. They force us to ask, what is space? Is it continuous or discrete? What is time? Is it made of instants or intervals? What is motion? Is it real change or just a series of static states? And here's the kicker. We still don't have perfect answers. We have mathematical tools that let us work with infinity and continuity. We have physical theories that describe motion incredibly accurately. But the deep philosophical questions, what these things are fundamentally, those questions remain open. Zeno didn't solve these puzzles, he created them. And in doing so, he gave us some of the most productive problems in the history of philosophy. Alright, before we talk about why all this matters today, there's one more paradox I want to mention briefly. It's called the Dichotomy Paradox, and it's a bit more technical than the others, but it reveals something important about Zeno's overall strategy. Imagine 3 rows of objects in a stadium. One row is stationary, the other 2 rows are moving past it in opposite directions at the same speed. Now here's what Zeno noticed. Relative to the stationary row, each moving row passes 1 object per unit of time. But, relative to each other, the 2 moving rows pass 2 objects per unit of time, because they're moving in opposite directions. So, which is it? Does 1 unit of time equal passing 1 object or 2 objects? How can the same interval of time contain both 1 unit of motion and 2 units of motion? Zeno used this to argue that if time is made of indivisible instants, smallest possible moments, then relative motion creates contradictions. The same instant would have to be both divisible, to account for relative motion, and indivisible, by definition. Now, I'll be honest, this one's trickier to wrap your head around and the details get pretty technical. The modern response involves understanding that velocity is relative and that there's no contradiction in different relative speeds. But Zeno was probing something interesting about the relationship between time, motion, and reference frames. Questions that wouldn't be fully addressed until Einstein's relativity. But here's what I really want you to see. Let's pull back and look at the pattern across all of Zeno's paradoxes. They're not random puzzles. They're not just Zeno being difficult for fun. They're a coordinated assault on our common-sense understanding of reality. Each paradox targets a different aspect of the world as we experience it. The plurality paradoxes attack the idea that many separate things exist. They show that infinite divisibility leads to contradictions about size and composition. The dichotomy attacks the possibility of starting or completing motion. It shows that infinite subdivision of space makes motion logically problematic. Achilles and the Tortoise attacks the possibility of catching up, of one moving thing overtaking another. Same structure, different angle. The arrow attacks the very nature of motion at an instant. It questions whether motion can exist in the present moment at all. The stadium attacks the coherence of relative motion and indivisible time. You see the architecture here? Zeno isn't just throwing random arguments at the wall. He's systematically dismantling the conceptual framework that allows us to make sense of plurality, space, time, and motion. And the method is consistent throughout. Reductio ad absurdum. Take what seems obviously true. Many things exist, motion is real, and show that it leads to logical impossibilities. This is what makes Zeno a philosophical genius rather than just a clever sophist. He's not playing word games, he's exposing genuine tensions in our conceptual scheme. He's showing that what we take for granted, what seems most obvious and undeniable, actually rests on assumptions that are philosophically problematic. Think about what he's done. He's made the ordinary extraordinary. He's made the simple complex. He's taken walking across a room and turned it into a profound metaphysical puzzle. And here's the thing, he's not wrong to do this, because these are puzzles. The relationship between the continuous and the discrete, between infinity and finitude, between instants and intervals, these are genuinely difficult problems. They're not solved just by saying, but obviously motion is real. Zeno forced philosophers to develop better tools, better logic, better mathematics, better conceptual frameworks for thinking about infinity, continuity, space, and time. Aristotle spent enormous energy responding to Zeno. He developed his theory of potentiality and actuality partly to address these paradoxes, his distinction between potential and actual infinity. That's a response to Zeno. Medieval philosophers obsessed over these arguments. They developed increasingly sophisticated theories of continua, of infinity, of the composition of matter. The development of calculus in the 17th and 18th centuries? That's partly about getting mathematical tools that can handle infinite series and infinitesimal quantities. Tools that let us work with the kinds of infinity that Zeno's paradoxes involve. And even today, even with all our mathematical sophistication, all our physical theories, we're still grappling with the fundamental questions Zeno raised. So when people ask, did we solve Zeno's paradoxes? Well, it depends on what you mean by solve. Mathematically, yes. We have rigorous theories of infinite series, of limits, of continuity. We can calculate with infinity. We can show that infinite sums can equal finite values. Physically, mostly, we have incredibly accurate theories of motion. We can predict trajectories, calculate velocities, send rockets to Mars, but philosophically, the deep questions remain. What is infinity? What is continuity? What is the relationship between mathematical models and physical reality? What is motion, fundamentally? These aren't just historical curiosities. These are live questions at the foundations of mathematics, physics, and philosophy. And that's Zeno's real legacy. Not the paradoxes themselves, but the questions they force us to ask. The way they make us examine our most basic assumptions about reality. So let's talk about why this ancient Greek troublemaker still matters today. Why you should care about arguments from 2,500 years ago. Why Zeno's paradoxes aren't just museum pieces but living philosophical challenges. So here's the question. Why are we spending all this time on arguments from ancient Greece? Why do Zeno's paradoxes still matter? Let me tell you, they matter a lot. And not just as historical curiosities, these paradoxes are still doing philosophical work. They're still challenging us. They're still revealing deep puzzles about reality. Let's start with mathematics. The development of calculus in the 17th century by Newton and Leibniz gave us tools for working with infinitesimals and infinite series. But it wasn't until the 19th century that mathematicians like Cauchy and Weierstrass put calculus on rigorous logical foundations. And you know what they were doing? They were responding to Zeno. They were developing precise definitions of limits, continuity, and convergence, mathematical concepts that let us handle infinity rigorously. They were showing exactly how infinite series can sum to finite values, how functions can be continuous, how we can make sense of infinitesimal change. This wasn't just abstract mathematics. This was addressing the conceptual problems that Zeno had identified. The theory of real numbers, the epsilon-delta definition of limits, the formal treatment of infinity, all of this is, in part, a response to Zeno's challenges. So Zeno's paradoxes literally shaped the development of modern mathematics. Not bad for some ancient thought experiments. But it's not just math. Philosophy has been wrestling with Zeno for millennia. Aristotle devoted significant portions of his physics to addressing Zeno's arguments. His entire theory of motion, his concepts of potentiality and actuality, his treatment of infinity, all of this is developed partly in response to Zeno. Medieval philosophers like Thomas Aquinas continued the debate. They developed increasingly sophisticated theories about the composition of continua, about how wholes relate to parts, about the nature of infinity. And modern philosophers? They're still at it. There's active philosophical debate about whether Zeno's paradoxes are truly solved, or whether we've just developed mathematical tools that let us work around them without fully resolving the underlying conceptual issues. Some philosophers argue that calculus solves the mathematical problem, but not the metaphysical problem. Yes, we can sum infinite series, but does that tell us what's actually happening when you walk across a room? Does it explain what motion fundamentally is? Others argue that the paradoxes reveal genuine features of reality, that space and time might not be infinitely divisible after all, that there might be fundamental discrete units. And here's where it gets really interesting. Modern physics is grappling with exactly these questions. In quantum mechanics, we've discovered that at the smallest scales, reality is quantized. Energy comes in discrete packets, quanta. There's a smallest possible length, the Planck length, about 10^35 meters. There's a smallest possible time interval, the Planck time about 10^43 seconds. So maybe space and time aren't infinitely divisible after all. Maybe Zeno's paradoxes point toward a fundamental discreteness in nature. But that raises new questions. If space is discrete, how does continuous motion work? Do particles jump from one position to the next? What happens at the Planck scale? And in relativity, Einstein showed that space and time aren't separate, they're unified into spacetime. Motion isn't something that happens in space over time. It's a feature of an object's path through four-dimensional spacetime. This changes how we think about Zeno's paradoxes. Maybe the problem was thinking of space and time as separate. Maybe motion isn't what we thought it was. But even with relativity and quantum mechanics, our two most fundamental physical theories, we haven't fully resolved the conceptual puzzles Zeno raised. We've reformulated them, given them new mathematical clothing, but the deep questions remain. What is time? Is it made of instants or intervals? What is space? Is it continuous or discrete? What is motion? Is it real change or just a series of static states? And here's something that should blow your mind. Some modern physicists and philosophers are exploring the idea that reality might be fundamentally computational, that the universe might be, in some sense, a kind of simulation or computation. If that's true, then reality is discrete at the fundamental level. Space and time would be pixelated, like a video game. Motion would be a series of discrete updates, not continuous flow. Zeno would have loved this, because it vindicates his intuition that continuous motion is problematic, that our everyday experience might not reflect fundamental reality. But even if the universe is discrete, we still have to explain why it appears continuous to us, why motion seems smooth, why space seems infinitely divisible. So the paradoxes persist. The questions remain open, and that's what makes Zeno's work so remarkable. These aren't just ancient puzzles that we've moved past. These are foundational questions about the nature of reality that we're still working on. Every time a physicist develops a new theory of quantum gravity, trying to reconcile quantum mechanics with relativity, they're dealing with questions about the structure of space and time that Zeno raised. Every time a philosopher writes about the nature of time, about whether the present moment is real, or whether only the past and future exist, they're engaging with conceptual territory that Zeno mapped out. Every time a mathematician works on the foundations of analysis, on making our theories of infinity and continuity more rigorous, they're continuing work that Zeno started. So when I say Zeno's paradoxes matter today, I mean it literally. They're not museum pieces. They're living philosophical problems. They're active research questions. They're challenges that each generation has to grapple with anew. And you know what's beautiful about that? It shows the power of philosophical thinking. Zeno didn't have calculus. He didn't have quantum mechanics. He didn't have computers or particle accelerators. He had logic. He had careful reasoning. He had the courage to question what everyone else took for granted. And with just those tools, logic and courage, he created arguments that are still challenging us 2,500 years later. That's what great philosophy does. It doesn't just solve problems. It reveals problems we didn't know we had. It takes what seems obvious and shows that it's strange. It takes what seems simple and shows that it's profound. Zeno looked at motion, the most ordinary, everyday phenomenon, and saw infinity. He saw a paradox. He saw deep questions about the nature of reality itself. And he forced us to see them too. All right, so let's bring this home. Let's talk about what Zeno actually accomplished and why his legacy matters, not just for ancient philosophy, but for how we think today. Remember at the beginning when I asked if you could actually move, and you probably thought, of course I can move. What kind of ridiculous question is that? Well, now you've been through Zeno's gauntlet. You've seen the dichotomy. You've watched Achilles chase the tortoise forever. You've contemplated the arrow frozen at every instant. And hopefully, you're thinking a little differently now. Not because you suddenly believe motion is impossible. You don't. And you shouldn't. But because you've seen that what seems most obvious, most undeniable, most basic about reality isn't simple at all. That's Zeno's first great achievement. He made us question our most fundamental assumptions. Think about what he did. He took plurality, the existence of many things, and showed it leads to contradictions about size and composition. He took motion, something you do constantly without thinking, and revealed hidden infinities, logical puzzles, conceptual tangles. He didn't do this by denying what we observe. He did it by following the logic of our beliefs to their conclusions. He showed that if you really think space is infinitely divisible, if you really think motion is continuous, you're committed to some very strange implications. And here's what's crucial. He wasn't wrong to do this. These are strange implications. These are genuine puzzles. The fact that we've developed mathematical and physical theories that can work with these concepts doesn't mean the philosophical questions are answered. It means we've gotten better at calculating with infinity, better at modeling motion. But what infinity is, what motion is, fundamentally, those questions remain. Zeno's second great achievement. He revealed deep puzzles about infinity and continuity that we're still working on. Look, infinity is weird. It's not just a really big number. It's something categorically different. When you have infinitely many things, the rules change. You can add something to infinity and still have infinity. You can remove something from infinity and still have infinity. Infinite sets can be put in one-to-one correspondence with their own subsets. This is strange stuff. And it's not just mathematical abstraction. It's about the structure of space and time, the composition of matter, the nature of reality itself. Are there infinitely many points between here and there? If so, how do you traverse them? If not, what's the smallest possible distance? And if there's a smallest distance, what does that mean for our understanding of space? These questions matter. They matter for physics, they matter for mathematics, they matter for philosophy. And Zeno was the first to really dig into them, to show that they're not just technical details but profound puzzles about the nature of reality. Zeno's third achievement, he created an enduring philosophical method, reductio ad absurdum, reduction to absurdity, has become one of the most powerful tools in philosophy, mathematics, and logic. When you want to disprove something, you assume it's true and show that it leads to contradiction or absurdity. This is everywhere now. Mathematical proofs by contradiction. Philosophical arguments that show a position leads to unacceptable consequences. Scientific reasoning that eliminates hypotheses by showing they predict impossible results. Every time you hear someone say, if that were true, then this impossible thing would follow, so it can't be true. That's Zeno's technique. He didn't invent logical reasoning, but he showed how powerful this particular form of argument could be. And he showed something else. That you can challenge even the most obvious-seeming beliefs if you're willing to follow the logic wherever it leads. That intellectual courage, the willingness to question everything, to take arguments seriously even when they lead to uncomfortable conclusions, that's a philosophical virtue Zeno exemplified. But here's what I think is most important about Zeno's legacy. He showed that reality isn't transparent to common sense. We navigate the world successfully. We walk, we run, we throw things, we catch things. Motion works. Plurality works. Our everyday experience is reliable enough for practical purposes. But Zeno showed that practical success doesn't mean philosophical understanding. Just because we can do something doesn't mean we understand what we're doing. Just because something works doesn't mean we've grasped its fundamental nature. This insight, that appearance and reality can come apart, that the world might be fundamentally different from how it seems, this is one of the most important ideas in philosophy and science. Copernicus. The Earth appears stationary, but it's actually moving. Einstein. Time appears absolute, but it's actually relative. Quantum mechanics. Particles appear to have definite properties, but they're actually in superposition. Over and over we discover that reality is stranger than it appears, that our intuitive understanding is incomplete or misleading, that we need rigorous reasoning, careful observation, mathematical modeling to get at the truth. Zeno was maybe the first in Western philosophy to really drive this point home. He showed that you can't just trust your senses and your intuitions. You need to think carefully. You need to follow arguments. You need to be willing to question everything. And you know what? We're still doing that. We're still discovering that reality is weirder than we thought. Quantum entanglement. Dark energy. The possibility that we live in a multiverse. The idea that consciousness might be fundamental to reality. Every generation discovers new ways in which reality is strange. New ways in which our common sense understanding is incomplete. Zeno prepared us for this. He showed us that strangeness isn't a bug in our theories. It's a feature of reality itself. Now let me be clear. I'm not saying Parmenides was right. I'm not saying motion is really impossible or that plurality is really an illusion. Most philosophers and scientists today reject Eleatic monism, but that's not the point. The point is that Zeno forced us to defend our beliefs. He forced us to develop better arguments, better theories, better conceptual frameworks. He forced us to take seriously the logical implications of our commitments, and in doing so, he made philosophy and science and mathematics better, more rigorous, more careful, more willing to follow arguments wherever they lead. Here's the quote on your slide. What is one. And if it is one, it has no parts. That's the Eleatic vision in a nutshell. Reality is one, indivisible, unchanging. Everything else is appearance. We don't believe that today, but we had to work hard to show why we don't believe it. We had to develop calculus to handle infinite series. We had to develop quantum mechanics to understand the discrete structure of matter. We had to develop relativity to understand the nature of spacetime. Zeno's paradoxes were the challenge that drove us to develop these theories. They were the puzzles we had to solve. They were the questions we had to answer. And some of those questions, the deepest ones, about what infinity really is, what time really is, what motion really is, we're still answering them. So here's what I want you to take away from this. Philosophy isn't just about old dead guys saying weird things. Philosophy is about questioning. It's about not taking anything for granted. It's about following arguments wherever they lead, even when they lead somewhere uncomfortable. Zeno embodied that spirit. He looked at the world everyone else took for granted and said, wait, let's think about this carefully. Let's see if it really makes sense. And it turned out that it didn't. Not as simply as people thought, anyway. That's what great philosophy does. It doesn't let you be comfortable with easy answers. It doesn't let you say obviously without backing it up. It doesn't let you take anything for granted. Every time you think, well, obviously things move, Zeno is there, 2,500 years later, asking, are you sure? Prove it. Show me how you get from here to there when there are infinitely many points in between. Show me how the arrow moves when at every instant it's stationary. Show me how Achilles catches the tortoise when there's always another gap to close. And those questions, those challenges to prove what seems obvious, those are still driving us forward, still making us think harder, still revealing new depths to reality. That's Zeno's legacy. Not the paradoxes themselves, but the spirit of relentless questioning they embody. The refusal to accept anything without argument, the courage to challenge even the most basic assumptions. And that spirit? That's what makes philosophy matter. That's what makes it alive, even after 2,500 years. Because reality doesn't give up its secrets easily. And the questions worth asking, the really deep questions about the nature of existence, about time and space and motion and infinity, those questions don't have simple answers. Zeno knew that. He showed us that. And we're still learning from him. So the next time you walk across a room, and you will, because motion is real, whatever Zeno might say, take a moment to appreciate how strange and wonderful it is that you can do that you can traverse space, that you can move through time, that you can complete what looks, from a certain angle, like an infinite number of tasks. Reality is stranger than it seems. And philosophy, good philosophy, rigorous philosophy, the kind Zeno practiced, helps us see that strangeness, helps us ask the questions we need to ask, helps us think more carefully about the world we inhabit. That's what we've been doing today. That's what Zeno started 2,500 years ago. And that's what we'll keep doing as long as there are people willing to question, to argue, to think deeply about the nature of reality. Because in the end, that's what philosophy is for. Not to give us comfortable answers, but to ask uncomfortable questions. Not to reassure us that everything makes sense, but to show us how much we still don't understand. Zeno did that better than almost anyone. And his paradoxes, those beautiful, maddening, profound puzzles, are still doing that work today.